fixed length subnet masking. So in this session, we are going to learn about variable length subnet masking. So what is a variable length subnet masking and how it is different from fixed length subnet masking? So let us discuss. Before entering into the session, let us all say our anthem that crack GATE and ESE with India's Get Plus subscription recorded lectures from India's topmost educators. Dear friends, now let us see. The example is like this. So a network is divided into three subnets as follows. Is supposed to give 120 HIDs, and the other part is supposed to give 32 HIDs. Subnet masking. So what is a variable length subnet masking? So the size of the networks are going to be variable. It's not. So in your subnet mask, if you consider, if I am saying that 255 and 255, then if I am masking consecutive 3 or 1, then it is called as uniform splitting. So which we are highlighted already in fixed length subnet mask. Variable length subnet masking, its scenario is different. Why its scenario is different? In V. Okay, 28 and 128 I want to do. Therefore, the first subnet already one is present. This is outermost, and one more bit I am using for innermost splitting, and the remaining are zeros only. So how many zeros you got? 2 power 6, which means 64 HIDs. So you got 64 HIDs, and we are performing innermost splitting also. So one bit innermost splitting will give you 2 parts. So we got 2 parts, and every part is dedicated with 2 power. Okay. Now let us do clearly. Your 256 HID, which is split into 2 parts. So one part got 128H and other part also got 128H. So let us write them. One subnet ID is n dot n dot n dot 0, n dot n dot n dot 0. What is your mask? 255 dot 255 dot 255 dot 128. Okay. So our first part got completed. Let us come to the second part. What is your second part? Subnet ID I am pulling as you have taken n n n, and what is the combination you have chosen? The combination you have chosen, as you chosen 0, now I need to opt for 1. There is no other way, because 2 power 1, 2 combinations only you are going to get. So the other combination I am writing. So 1. And you don't forget here one important thing. What is that? The second bit, because the second group is got subnetted second bit also. Understand? 2 ones in your subnet mask, you have got 2 ones and 6 zeros. The first one is for outermost and the second one is for innermost. So from outermost part, as we choose in 0, outermost part in your IP, he chosen 0 at the subnet ID. So I need to choose another alternative, that is a 1 subnet ID. Okay. 1 is nothing but is a 128 subnet ID. So your new subnet ID is here n dot n dot n dot 128. Hold on. And now this second group is further divided into 64 and 64. Therefore, this bit, the second bit, is also going to perform subnetting. So again you need to perform, because one bit subnetting, innermost subnetting is happened, so you need to take a 2 power 1 combination. So you're going to get 2 power 1 innermost. I am doing 2 combinations you will get. What are 2 combinations? Innermost subnetted. Again use is changed. Double one. What is your double one? Triple N. Double one means 192. Mask only. What is your mask? 255.255.255.192. This, what is the subnet ID? N dot n dot n dot 0 slash. Your mask is 255.255.255 and 120. Okay. So what are the range of the IPs are there in first and second subnet? So the range of the IPs which are there in first and second subnet is subnet group. It has got 2. Inside you are having a 2. What is that? Please observe. N dot n dot n dot, you have chosen 128. He has chosen 192 because it happened 192. So what is the range of the numbers? This is your starting number. Ending number is 191. So 128 to 191, how many HIDs? 64 HIDs. And here also starting number, your last number is 255. So here also is your answer. So as we are learning for the first time, I have drafted this much. Next we are going to do bit quickly. You also follow carefully. So I want to do class C subnet. Class C network is a subnetting as follows. 100, okay, and group 2, how many? 50 HIDs, and group 3, 75 HIDs. Can I able to keep these many IP addresses in class C? Let us check. So 100 plus 50, 150 plus 75, total HIDs are 250. Log base 2 of your 50. So I can write 2 power 6 greater than your 50, because 64 greater than your 50. Then I am taking 6-bit HID format. Okay. Now let us write your mask. 255, 255, 255. These are all 3 NID. And you need to keep only 6 zeros in your HID part. And the rest of the 2 bits are going to be ones only. So what is the meaning of it? 255 dot 255 dot 255 dot 192. So how many HIDs? Dash HIDs from this group is 255 7 zeros, and the rest of the bit is 1 only. So what is your new mask? 255 255 255 and 128. That's it. So you got 3 masks. So you want me to find how? Let us check. So subnet masks we got. What is your first? It is a 128. So 255.255.255.128. And your second subnet mask is 255.255.255.192. Your third subnet mask is same like your first subnet mask only. 255.255.128. Okay. This will give you almost all 128H. So what is your left hand side? Your mask is 255.255.128. 1 bit outermost is subnetted. Very important question, my dear friends. FLSM anybody can do, but VLSM is very tough. Now, so what is a 128? Let me write now. So 255.255.170. Now innermost we want, and each part is consisting of 64 HIDs. Now you tell me what is your new mask after inner splitting. Your new mask for group 1 and group 2 is 255.255.255. 1 bit for outermost split. Now let us take group 3 and 4. Group 3 and group 4. So after doing outer split, after 3, 4, 5, your mask for group 3, 4, 5 NID. So outermost and innermost two consecutive 3 ones is nothing but 220. Okay. Now let us do subnet IDs for them. So subnet IDs are nothing but, so somebody has to choose 0, somebody has to choose 1 from outermost splitting. So take your class C IP. What is your class C IP? N and 1, 2, 3, 4, 5, 6, 7, 8. This is your class C IP. Any number you can take it, class C. For example, 192, 168, 100. If I am taking 0, so I am writing 0. Now, 1 bit subnetting I am doing. Outermost first let me do. So when you do 1 bit subnetting, so this is the subnetted position. The rest is HID position only. Please recollect. So this is a subnetted position. Therefore, what happened? This is going to be the result. So I am using 0 and somebody is taking 1 combination. So N. Somebody will take 1 combination and the remaining are zeros only. You may also swap them, no problem. So he can start with the 1, he can start with 0. Right? No problem. You can do that swapping. Combination can be anything. So innermost splitting is happened. Sorry, outermost splitting is happened. So after outermost splitting, what are your subnet IDs? Your subnet ID is n dot 0. This is subnetted 1, 2, 3, 4, 5, 6, 7. And this side also triple N. This is for inner. If then you got 2 groups. One group is n dot outer, inner 0 and 6 HIDs. And the other guy will take n dot outer we don't disturb. And inner, as you choose in 0, you have to choose 1. Otherwise, you can interswap. He may choose 1, you can also choose 0. No problem. Anything is correct. So this is your inner. And so outer, as you choose in 0, he choose in 1, and inner, the first guy choose in 0, second guy will choose 1, and the rest are zeros. Okay, this is for outer and this is for inner. So what are your subnet IDs now? Tell me. Your subnet ID for group 1 is n dot n dot n dot 0. Your subnet ID for group 2 n dot n dot n dot. What is the value? 1, 2, 4, 8, 16, 32, 64. Okay. So 2 subnets we got. And each subnet cost how much? 64 HIDs. This is also 64 HIDs. So come to this side. So this is your outermost, which happened already. Now you need 4 parts here. Therefore 2 bits are. So your zeros are only 5 bits. Okay. So let us do group 3. So n dot n dot n dot, outer is 1 and inner 0 0 0 1 1 0 1 1, that combination you write. If I am taking 0 0 and somebody group 4, he is taking n dot n dot n dot, 1 is outer, he is choosing 0 1 combination, and the other guy group 5 n dot n dot n dot, if you choose 1 0 combination. So 2 power 2, 4 combinations I am. So this is for inner, this is for inner combination, this is also inner, and don't forget to write outer. Outer 1 is a carry forwarding, this is your outer. So write remaining zeros over there. So how many zeros? 5 zeros. So you got your answers. So 32 HIDs you got, 32 HID you got, 32 HID you got. So triple N dot, what is the value? 128. Triple N dot, what is the value? 128 plus, what is this value? 1, 2, 4, 8, 16, 32 plus 128, 160. N dot, N dot, N dot, what is the value? 128 plus 64, it is 190. Stop it. So you got your answer. So subnet masks we have calculated and the subnet IDs also we have calculated. Okay. Your range of IPs I will write finally. Observe. Group 1 0 to 63. Group 2 number 127. Okay. So group 1 n dot n dot. Otherwise let me write your IP. What is your IP you have taken? 192, 168, 100. 0 to 192, 168, 100.63. Right? Because next is 64. Before that number used. This is about group 1. What is group 2? 100. It is 64. 2. 192.168.100 dot. Before the next subnet number, that is 127. And group 3. So 192, 168, 100. 128 to how many? 192, 168, 100. Before number of your next subnet. Your next subnet is 160. So 159. Next group 4. 192, 168, 100.162. 192.168.100.191 because next subnet is 192. So 192.168.100.192 to 223. That's right. So this will give you 32H, 128 to 159. This will give you 32H. This will give you 64H. This will give you 64H. That's it, my dear friends. So we will continue VLSM in the next session by taking random splitting and some advanced problems. So we'll meet